It is probably not surprising we'll begin the math course with a discussion of counting numbers, or the natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Lesson 1 builds upon that to discuss whole numbers, which include 0, and then integers, which include -1, -2, -3, and so on. And from there we build up other number types as well, all of which form the foundation of mathematics and allow us to count things in the world around us, like a soccer ball. Okay, that may not be the first example that came to most of your minds, but a soccer ball is kind of interesting, especially for those of you in 9th grade who are going to power through all the way to lesson 10 and discover Euler's formula for polyhedrons, which is on the SHSAT exam. The entire surface of a soccer ball is made up of 12 regular pentagons and 20 regular hexagons. Each of those are polygons we will learn more about in lesson 2. In total, that amounts to 32 faces, another integer at play. And among those 32 faces, the total number of sides is 180. And on that soccer ball, which shares 2 polygon faces for every edge, really, that's half that, or 90 edges. Again, integers at play. And thanks to Euler, he tells us that a soccer ball, a sphere of Euler characteristic 2, must therefore have 60 vertices, or 60 points, where all the lines come together on a traditional soccer ball. No Jabulanis or fancy new soccer balls included, not for this discussion. Now you might find all these integers and the theorems interesting in their own right. However, that's not exactly why we want to use a soccer ball today. We're going to take our soccer ball out to the park and play a game. Not a game of soccer, but a game of integers, in order to see how counting can shape our view of the world we live in. So imagine for a moment our soccer ball were the sun. Place that soccer ball right down on the field in the park. Walk about 20 paces away, and now we're going to place the earth. What object do you think we might use for the earth, given that the sun is represented by a soccer ball? Okay, now that you've given it some thought, the answer is a pinhead. The earth is less than 1/100th the radius of the sun, or the soccer ball in this case. So place your pinhead down to represent the earth. That pinhead represents the place where everyone you know, everyone who's ever lived, resides. Now proceed to walk about 100 meters out from your soccer ball. Place a ping pong ball on the field. What do you think that ping pong ball represents? Yeah, you probably guessed it. It's the massive planet in our solar system known as Jupiter. Now, with another soccer ball in hand, look up and let's think about how far I have to travel to put my next star, my next soccer ball, down on the ground. Count to 2,000. 2,000 what? Paces further? No, not that simple and not that close. Oh, perhaps 2,000 meters. We're a little over a mile away for that soccer ball. Nope, still not even in the ballpark. Well, some students might say, oh no, you've got to go to the other side of the city. And others still might say, no, it's even further than that. If I'm standing in New York, I might have to go all the way to Washington, D.C. to put my soccer ball down. Or from Washington, the reverse, all the way to New York. No, it's still not that simple. 2,000 represents the amount of miles I would have to walk to put my soccer ball down that represents the next star. Good luck seeing your original soccer ball, let alone that pinhead, from 2,000 miles away. So your image of our solar system might have been formed from a poster you saw in science class or in a book, or one of those mobiles hanging from your ceiling as a child. Either case, they really didn't offer the correct perspective. Knowing the real relative counts can change your view on the world. And that's the beauty of mathematics. So let's begin our journey in math in this course to take you to the SHSAT and beyond.